So topic 5, test review for geometry. These numbers 1 through 8. Okay, why do you think I put these vocab terms on here?
We might forget
Yes.
about them.
Okay, the reason I put them on here is yes, they will probably be on your test, but also if you know what they are, it'll help you throughout the rest of the test. Okay, once you know what they do and how they work. So on number 1, if I draw a triangle, how would you describe a median to me?
3 lines.
Doesn't necessarily have to be.
Side to
It goes from a vertice to a side. What does it do to that side? Splits that side in half. Yep, so if I told you line AB, that's a median. Okay, it goes from a vertice to another side, splitting that side in half. What if I asked you about altitude? What's that do? Or what is an altitude? Yep, vertex to an opposite side, what does it do? It's the right angle. Yep, altitude is our right angle there. And altitude does not split a side in half, okay? Altitude just creates that right angle. So here, if I labeled this, line AB would be an altitude. Okay, remember, sometimes can altitudes be drawn outside the triangle? Yes, okay, those both there that I drew would be an altitude. Okay, what about an angle bisector? What is that and what does it do?
It divides an angle.
Yeah, so if I have an angle here, if you ever see the term angle bisector, we know that there's a line. If I call this line AB, it splits this angle in half. Okay, whenever you see the term bisector, that means it's splitting something in half. Okay. What about a perpendicular bisector? Again, I have a triangle here. What's a perpendicular bisector? Yeah, so if I draw a line from vertice to opposite side, I agree, it splits this in half. What else does it do? Right angle. Yep. So do you agree a perpendicular bisector is a mix of a median and an altitude? Yes, it's a mix of the two. Okay, so perpendicular bisector splits the side in half and creates a right angle. So line AB would be a perpendicular bisector. What about vertices? I know this was a very vague vocab term. Okay. Specifically, if I had a triangle here, because that's what this chapter was about, and I label these A, B, and C. What are the vertices of a triangle? It's the corners, right? So the points. So A is a vertice, B is a vertice, and C is a vertice. Okay, vertices are also on other shapes. They're on every single shape but a circle. Okay, so points on or corners on a shape, those are all called vertices. Okay. Number 6, it's been a while. Point of concurrency, what does that mean? It's where the two lines meet, right? Does it have to be 2 lines? Can it be more than 2 lines? It can be as many lines as you want, just as long as they all meet at the same point. It's a snowflake. Let's not speak snow into existence yet, though, right?
No. Yes, we want Christmas time.
I know, we need a white Christmas, right?
We don't.
And we need snow days, that's the most important.
Christmas, because then we get snow days, and then our power's out for 5 days, we don't come to school.
Anyways, sorry, got us off track.
Let's go, Mark.
That point right in the middle, that is your point of concurrency. That's where they all meet each other. Okay. So last couple, number 7 and 8, is the difference between a circumscribed and an inscribed circle. Okay, go for it.
The circumscribed circle is like a circle with a triangle in it.
Right, so if I have a triangle here, that circumscribed circle is on the outside. Now, does that just mean this?
No.
No, what does it mean?
It's on the point.
Touches the vertices, right? So that triangle kind of creates the circle here. Okay, that is a circumscribed circle because all 3 vertices touch the edge of the circle. Okay, what about an inscribed circle?
It's the circle inside the triangle.
It is a circle inside the triangle. Now,
It has to touch like.
does that just mean this?
No, it has to.
No,
It has to touch the side.
it has to touch the sides. Okay, it is embedded in that triangle there.
Inside. Inside.
Yes, that's a very good way to remember it. Inscribed, the circle is inside. I don't have a way to remember this one. But inscribed is inside. This one's just the other one. Okay, inscribed inside. Okay. Any particular questions with these 8 vocab terms?
No.
Gonna make me retake this one.
9 through 10, even though the directions say 6, 7. Ha 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 ha. I did that on purpose.
Leave.
Anyway, number 9 and 10. I know the diagram gets a little messy because they have all these arrows with a bunch of labels here. On the test, it's not this messy, okay? I made sure it wasn't with all a bunch of arrows. Okay, but in here, it will give you the information you want to know. Okay, so EM is 6. Okay, and it wants us to find the two, the whole thing and the other part. Okay, so we always want to start with what we're given, just like we did with proofs. What else do we know about EM?
It's 2/3.
Yeah, what fractions are we always going to use?
2/3, 1/3.
2/3 or 1/3. So EM, this is the bigger half, so it's the EM equals 2/3 of what? EL, right? What can I do here to solve? Yes, plug 6 into here, so we have, I'm going to come over here so I have more room. 6 equals 2/3 of EL. How do I get rid of that fraction?
Multiply by 3.
Multiply by that denominator. So we get 3 times 6 is 18. Remember, these 3's cancel each other out, so what's left? 2EL. What's my last step there? Divide by 2. We get EL equals 9. Okay, so we found the whole thing is 9. How do I find the missing part?
Just do 9.
That's the easiest way, right? Could you do the whole 1/3 route? Yes, but is it so much easier to just take 9 minus 6,
Yes.
which is
3.
3. So you get ML equals 3. You guys did a nice job on your homework. Just make sure you label which one is which. So like ML and EL. Let's take a look at number 10. Number 10 says DM is 8. What else do we know about DM? It is the bigger half again. Okay, is it always going to be the 2/3? It will not always be the 2/3. So we have DM equals 2/3 of what? DK. Donkey Kong. What do we do from here? Yeah, we want to plug 8 in, right? So 8 is going to be plugged in for DM. So this turns into 8 equals 2/3 of DK. Yep, get rid of that fraction, multiply by the denominator. So we get 24 equals, what's left? 2DK. Last step, divide by 2. So we get DK equals 12. So if I come back up to the picture, we just found that this whole thing is 12. How do I find the missing part? Simple subtraction. 12 minus 8 equals
MK equals
4. So yes, we know MK equals 4. Yes, sir.
Are you still locking points for not trying to work on these?
Do you have the answer right? No.
Okay.
Okay. I want to talk about one more example just in case it may show up on your test tomorrow. So if I told you, and you can go ahead and write this off to the side or in this empty space that you have up here, just so you remember. If I told you that FJ is 15, okay, and it wants us to find FM and MJ. So we know the whole thing is 15. Doesn't matter which part we find first. It doesn't, right? Do you guys want to find FM or MJ?
FM.
I heard FM first, okay? So if we pick FM, we got to know, what do we know about FM? FM is the 2/3 side of the whole thing, FJ. What do we do from here then? Yeah, we're going to plug 15 in for FJ. Now, does that just go over here? No, plug it in for the, yeah, I just want you to understand that you're not always going to plug it in on this side. Okay, you're plugging it in for what it stands for, which is FJ. So if I solve this, we have FM equals 2/3 of 15. Now, there's a couple different ways you can solve this. I'm just going to stay consistent. Okay, so how can we get rid of that fraction? Multiply by 3. So we have 3 FM equals 2 times 15 is 30. What's my last step here then? Divide by 3. So we get FM equals 10. Okay, so I found FM is 10. How would I find MJ then?
15 minus 10.
Yep, subtraction. 15 minus 10 is
MJ equals 5.
5, so we know MJ equals 5. Okay, so there's another way. you can see that if they end up giving you the whole length. Moving on to number 11, okay, this one's asking what are the possible values for x, okay? My recommendation here, because we tend to get, whether we need to find the range or just one value, we tend to get that confused, okay? So on this, I just recommend you start with your algebraic expression. So what is my algebraic expression on number 11? X minus 13. Ask yourself, what is that representing? An angle or a side? It's representing an angle. If you're struggling with that, most of the time it's going to have a little degree symbol there. Okay, so this is representing an angle. So what do we want to compare it to? We want to compare it to the other angle, which is 75. Okay, are those two angles equal to each other? Why not?
Because of the side.
Their sides are the same. So we have to decide, is x minus 13 less than or greater than 75?
Less
It is less than. Why?
because its side is smaller than 75.
It's across from the smaller side. So we know x minus 13 has to be less than 75. Does the direction of this side matter?
Yes.
Yes. Okay. How do I solve here then? At 13. So we end up getting x is less than 88. This is all you need for these. Number 12, it says a triangular pendant. Does anyone know what this is?
A triangle.
It is, okay, I'm glad you said that. It is a triangle, okay? If you were wondering what a pendant is, it's this, like, kind of similar to my Wayne State thing up here. That's what it's talking about, okay? But you need to just understand they're talking about a triangle shape, okay? So triangle says it has side lengths of 23 or 31. It wants us to find the possible lengths of that third side. Now, does that third side only have one length? Or could it have multiple?
Could have multiple.
Could have multiple. Okay, so how many scenarios did we come up with? 2 scenarios. What's one of them?
31 minus 23.
Yeah, so what you're getting that from is, could 31 be our biggest side on this triangle? Yes. So we know these two would have to add up to be greater than that biggest side. So I can take 23 plus x to be greater than 31. So how would I solve this here? Subtract 23. So 31 minus 23 is 8. There's one scenario. For our second scenario, you have to think, could this side be our biggest side?
Yes.
Could, right? So these two would have to add up to be greater than that x value there. So 23 plus 31 would have to be greater than x. What's 23 plus 31? 54 is greater than x. Okay. What happened a lot is that a lot of us left our answers in this form. What do we need to write our answer as? Compound inequality, okay? You are always going to write your compound inequalities from least to greatest. Never write it from greatest to least, okay? So what is the least value of our compound inequality? 8 is less than x, which is less than 54. This is your range for what that side could possibly be. All right, on the back side, on number 13 through 14, we're using this diagram here. Number 13 just wants us to find the value of y. Any ideas here? They are going to be equal to each other. Does anyone know why they are going to be equal to each other?
Because it's split in the middle.
It is split in the middle, and
They're congruent. The sides are, or the bottom sides are across from.
do you agree this side is also the same?
Yes.
So what theorem does this match? Yes! Side, side, side. Okay? No, you do not have to tell me that on the test. Okay? But this is the reason we can assume that those angles are the same. Yeah.
Oh, you go.
Me? No, because I already give you bonus IXLs. So, we have 3y plus 4 equals 5y minus 10. Don't be lazy with the solving for the algebra. We made some silly little mistakes on our homework the other day because we're going too fast. How do I solve this? You say minus 4? Minus 4? So I have 3y equals 5y minus 14. What's next? Subtract 5y. I'm going to come over here because I ran out of room. Negative 2y equals negative 14. What's last? Divide by negative 2. We have y equals 7. Okay, and then on number 14, it's asking for the measure of angle DEF. Is that the whole thing or half of it? It's the whole thing. Make sure you draw this out so you know you're finding the correct thing here. They are talking about that whole angle here. How do we find that angle measure? A couple different ways. It's putting it in for the y, right? Do you need to plug it in for both of them? No, you can only just pick one, right? If you want to do both of them, you can. So I'm just going to pick this one, but it doesn't matter which one you pick. I'm going to take 3y plus 4. What do we get for y? 7. So 3 times 7 is what?
21.
What is 21 plus 4? So we get 25. Is this my answer? No. How do I find the whole thing? Yep. Take 25 plus 25, or you can double it to get 50. So 50 is the correct answer for angle DEF. All right, number 15. I rewrote these angles in here for you because it was very hard to read. But it says list the side lengths in order from least to greatest. Do we have enough information to say that yet?
Not yet.
You guys probably do now on your review, but right now, looking at mine, do I? No, what do I want to find? Yeah, I want to find this angle measure just to be sure which side is the smallest and or the biggest. Okay, so we can take 60 plus 68, which is 128. What do I do with that 128?
You subtract it from 180, and you get
52. So we get 52 for there. So now it wants us to list the order from least to greatest. This is always going to be least to greatest for me. I will not switch it on you, okay? Just always know least to greatest. Some of us are flipping that, okay? What is my smallest angle? F, 52. So what's my smallest side going to be? GH. Could I put HG? Yes. What's next? HF, good. And then last, GF. All right, number 16, it says, can side lengths of 6, 15, and 12 make a triangle? How do we figure that out?
You add the two small sides, you have 6 and 12.
Yeah, what I saw in our homework a lot is we just took the first two numbers. Is that what we want to do? No, what do we want to do?
You're going to add the two small.
Two smallest numbers. So we take 6 plus 12, which is 18. What does 18 have to be?
Bigger than 15.
Has to be bigger than the biggest side. Is that true? Yes. Recap. Can I have this?
No.
No. Cannot have that. Okay, so it always has to be bigger than that biggest side. Okay. Number 17. On this one, a lot of us were trying to do it without labeling things. Okay, so we were just taking this information and just trying to look at it without physically writing it in. Okay, so I really do think it helps to go into the picture and write it. Okay, so we know PQ, this line here, is negative 2y plus 15, and PS is 3y plus 5. It wants us to find the radius of an inscribed circle. What's an inscribed circle? It's a circle on the inside, so it doesn't give it to us, so it's probably best that we draw it there. That was a pretty good circle, if I do say so myself. Okay, if I have a circle here, little elementary review here. What's a radius? What'd you say? It's half, right? So from the center to the outside, if you need to draw this, this is the radius. Okay, what if it asked you for the diameter? What's the diameter? Diameter is the whole thing from here. This whole thing right here is the diameter. So radius is half of the diameter. Okay. So we just said the radius is from the center to the outside of the circle. Do you agree PQ is a radius? What about PS? Okay, so what do you know about those two then? They should be equal, right? So to solve, we can set negative 2y plus 15 equal to 3y plus 5. How do I solve here? Add 2y. So we have 15 equals 5y plus 5. Subtract 5. So we have 10 equals 5y. Last step. Divide by 5, so we get y equals 2. Is that my answer?
No.
No. A lot of you are going to think it is. But we want to find what the radius is. How do I find what the radius is? Plug it in. Does it matter which one I plug it into? No. I'm just going to choose this one. So 3 times 2 is 6 plus 5, 11. So the 11 is the radius. What would you do to find the diameter? You would take that times 2, or 11 plus 11. Okay, so your diameter in this case would be 22. Yep. Awesome. What if it gave you a, asked for the circumscribed circle? That's the outside one. Yep, outside. Okay. Even though it's a circumscribed circle, does that change the definition of a radius? No. Radius is still from the center to the outside of the circle. Okay. Last one here. Number 18. It says if CD equals CF equals 7. So we know these two lines right here equal 7. And also tells us DE is 3B and EF is B plus 58. It wants us to find the value of B. Does anyone know where I got this problem from? It is from the bonus IXLs. Yep. What do we think here?
Subtract that b to the 3. The 3b minus that b.
What are you setting up here?
I just did it in my head from the IXL.
There we go. That's what I'm looking for. We know these two sides are equal to each other, right? Does anyone know the reason they're equal to each other?
Oh, because of the right angle, it has the perpendicular bisector.
We do have a perpendicular bisector here, and remember, F and D meet at the same point E, so we know those have to be the same. Okay, so I can set this equal B plus 58 equals 3B. Now, it was really funny yesterday. A lot of us were confused because it was just a B here. Can you put an X in there if you wanted to?
Yeah.
Yes. Okay, how can I solve?
Subtract that b.
Subtract B.
Divide by 2.
So I have 58 equals 2B. Yes, last step, we divide by 2. B equals 29. And that's all I wanted on that one.
Yeah, you confused me for a second. I just did it in my head.
Okay. Any questions on the backside? All right.